Happy day to my dear students and friends. This is L. Nagarajan working as an assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering, Trichy, aggregated by NAC, approved by AICT New Delhi, affiliated to Anna University, Chennai. So in today's class, we will discussing about the recording problems in the electrodes. Okay, so far we had a small glance in the previous video. Um, we had a small video about the different types of electrodes and materials used in the electrodes and equivalent circuit and application of each electrodes. And today we are going to discuss about the electrodes problems, recording problems in the electrodes. Okay, so in observing the measurement of biosignals, it is required to measure the electrodes in the surface of the body. Okay, then efficient measurement of the bioelectrical signal can be acquired, okay, with the proper design of the electrodes. So the proper selection of the electrode is very important in order to measure the proper signals. Okay. And few problems will occur during the recording or fabricating the electrodes. Okay, so those problems we are going to discuss now. First one is measure and error. Okay, first one is measure and error. Next one is material used for fabrication in transducers, sensors. Next one is signal conditioner and display system. And the calibration problem will also occur. And finally, the contact impedance. So we will have a small glance of each and every topic. First one is measure and error. Okay, so during the biosignal recording, the physical condition influences the readings. Okay, influences the readings. For example, the temperature. Okay, and let me complete that one. The physical quantities or physical conditions, okay, leads to the analysis of the electrode signal in the measurement system. Okay, the major problems in recording is the environmental error in electrode recording. Due to the environmental error, what are the environmental error will be there? Temperature, humidity, vibration. So here is some examples. First one is temperature. Okay, now you are going to measure the fever of a patient in an AC room. Keep in mind, when you measure the temperature of a patient, okay, in an AC room, obviously it is an awkward situation. That is immediately when you remove the thermometer from a body, then it will drop the temperature. The meter will show the huge difference. Okay, and again coming to this humidity. Okay, humidity also this environmental based, and vibrations. Okay, vibrations, and suppose if you want to measure the EEG, okay, the patient should sit ideally. There shouldn't be any vibration. If there is an vibration, then that vibration causes an change in waveform in the outputs. Then by looking at that reading, that is the improper reading, then there will be a prescription of wrong medicines to the patient. That will lead to difficult and tough situation for the patient. Okay, so the measure and error is important. And one more thing is to be added here is the technicians. Okay, technicians should have a sound knowledge in the usage of that equipment. If that technician does not have any knowledge in that in operating that equipment, then obviously the whatever the reading he is taking will be entirely different, and the doctor cannot prescribe any medicines to that type of readings. Okay, so if we do so, then the patient again he will feel very tough situations. Now we are going to discuss about the material used for manufacturing the transducers sensors. Okay, for good interfacing, okay, between the transducers and that is the tip of the electrode and the cell, this material must be a good conductor. Okay, the material must be a good conductor. So what type of materials usually used in this type of electrode manufacturing will be silver, silver chloride, tungsten, and in few cases gold also utilized. And what is this material used influencing the recording output of the electrode? Okay. Various depth in brain along with certain axis is required, and simple multiple depth electrodes have been used for this purpose, and fine insulated wire placed on the tips, good interface with suitable materials. And okay, and usually the electrodes utilized, okay, the electrode utilized in the manufacturing of this, the material utilized for the manufacturing of this will be less, availability will be less, and it have a good electrical conductivity and low resistance. That is why we are using the silver chloride and tungsten materials. We cannot you go for some iron or aluminum or some other material, because those material have very high resistance, and it will provide a very high contact impedance. And if there is very high contact impedance, then it is very difficult to pick the electrical signal, bioelectrical signal, because this bioelectrical signal and noise will be the same. Okay, it resembles the same, it looks like the same, with the same frequency and the same amplitude. So it is very difficult to classify the bio signal and noise. Okay, that is the thing we are going to look at next slide. So that is a signal conditioner. Okay, the signal conditioner, what is the role of a signal conditioner? As I said just before, the biosignals and the noise will looks like same. Okay, both with the same amplitude, both with the same frequency. Okay, both are almost resembling each other. So this signal conditioner unit is utilized to pick the exact biosignal from the noise, and that signal should were utilized for the amplification purpose, storage purpose, display purpose, everything. Okay, so this biosignal conditioner, that is signal conditioner unit, will have amplifiers, okay, in order to amplify the low level weak signal biosignals to the desired level for the processing and storaging, that is manipulating, storage, everything. So few signal conditioning components are proper resistive network, then multi-stage amplifiers will be there, and the signal which you are getting will be in the form of analog. Okay, that analog has to be converted into digital for storage purpose and display purpose and transmission purpose, everything. And again, when the thing has to be displayed, this digital has to be converted into analog, because the readings, the graph, the output will be in the form of analog. Okay, by looking at that waveform, the doctors can able to understand the performance of the unit where it has been placed for the measurement. Next one is display unit. Okay, this display system, after the biosignal acquisition, the display system is used to show the processed output. Okay, this display system is a part of the recording system. Okay, is a part of the recording system where it will record as well as display the signal. Okay, the display system unit will reduce the observational error. Okay, this observational error is the error that happens in the initial stage. Okay, if the technician is not that much experienced, then he will have some variations. Okay, he will report, he will write and report with wide variations, so that can be eliminated using this display system. This will give accurate value. Okay, then it includes the scale, okay, and the chart, okay, and even alarm system also there. Okay, when there is a scale, then it is very easy to measure the values, and chart is also there, and alarm signal is also there in order to monitor the abnormal condition of a patient. So these are the display systems. Then energy sources. Another input factor to be considered is the energy source. Okay, so what are the energy source were used? That is AC source and DC source. Whereas in biomedical instrumentation, usually they will use DC source, because when we are using AC source, then that will create an electromagnetic interference. Okay, this EMI wave will cause an change in the biosignals, and it will have a very bad impact over the biosignal, and we will get an faulty readings. Okay, and finally the calibration and impedance, contact impedance calibration. This calibration must be done after every patient. Okay, because if we miss this calibration, the already set predetermined value for the previous patient will remain same in that system. Okay, when if it is not calibrated and the same is connected to the current patient, then the readings will be entirely different. Okay, so to do the calculations and to do the signal transmission, this calibration unit must be properly done for every patient. Okay, and finally contact impedance. Okay, what is this contact impedance? So when we are measuring an ultrasonic image in an for a baby in a fetal, then they will be using an electrode paste. So what is the use of the electrode paste? First, it will provide a lubrication. Okay, it will provide a lubrication for the electrode to move smoothly on the surface of the skin. And the second one, it provides a good contact between the electrode and skin. Okay, and finally it also reduces the noise. Okay, because when we move the electrode on the surface of the skin with more hairs, then there will be a noise of the hair. Okay, and there will be some air bubbles also. Air bubbles in the sense, if we move, then there will be some air in between the electrode and the surface of the skin. So all these things can be reduced, that is air artifacts and motion artifacts. Okay, air artifacts, this is the gap between the electrode and the skin, and that is called as air artifacts. And motion artifacts is it is a pair of electrode, the electrolytes, and one moves while other remains stationary. Okay, due to the movement of electrode during the recording motion, artifacts will occur. So here is that's all with the surface, that is error due to the measurement, and hope you understand. The next we will discuss the basic biomedical instrumentation and its components in the next class. Thank you.